Hello everyone and welcome back to the best investing podcast in the world. Today I'm going to be reviewing Nvidia's Q4 2024 earnings digest and why I believe they are incredibly bullish for both Palantir and AMD. Let's get deep into it. The latest Nvidia earnings report gave me additional clarity on two things. One, the continuity of the AI bull market, which is tremendously bullish for Palantir, and two, AMD's competitive advantage versus Nvidia. Starting with the former, Jensen explained that we now have two additional scaling laws which are driving a 100x increase in the demand for compute. These are the post-training and reasoning scaling laws. The former consists in improving models over time once they've been deployed, and the latter is about getting models to think deeply versus just perform one-shot inferences. Jensen's remarks about this during the Q4 2024 earnings call were fascinating.
The traditional scaling laws of AI remains intact. Foundation models are being enhanced with multimodality, and pre-training is still growing. But it's no longer enough. We have two additional scaling dimensions. Post-training scaling, where reinforcement learning, fine-tuning, model distillation require orders of magnitude more compute than pre-training alone. Inference time scaling and reasoning, where a single query can demand 100 times more compute. We designed Blackwell for this moment, a single platform that can easily transition from pre-training, post-training, and test time scaling.
The AI market has thus far been propelled by the pre-training scaling law. As we've added more parameters to the models and thrown more computation at them, they've been getting exponentially smarter. This has ultimately driven positive returns on AI capex, which has kept the bull market alive for the AI companies across the value chain. Per Jensen's words, these two additional scaling laws are thus set to accelerate the progress of AI further, which will hypothetically drive higher returns. As Jensen explained during the call, Nvidia customers make more money per every increment in the aforementioned scaling laws.
And then the third thing I would say is that our performance and our rhythm is so incredibly fast. Remember that these data centers are always fixed in size. They're fixed in size or they're fixed in power. And if our performance per watt is anywhere from 2x to 4x to 8x, which is not unusual, it translates directly to revenues. And so if you have a 100 megawatt data center, if the performance or the throughput in that 100 megawatt or that gigawatt data center is 4 times or 8 times higher, your revenues for that gigawatt data center is 8 times higher.
Going back to Palantir, during the call, Jensen also said that they see the next AI wave coming up, and this is agentic AI and then physical AI. The world has been focused on LLMs for some time now, but Jensen says that agents and AIs that understand the physical world are on the horizon and that they will be much bigger than what we have seen to date. What this means for Palantir shareholders is that Palantir's operating margins and free cash flow per share are likely to continue growing exponentially from here, perhaps even faster than we have seen to date. The main driver of Palantir's financial outperformance over the past year has been AIP, which in turn has been enabled by the rapid advancement of LLMs. As I have explained recently, Palantir's future is about creating autonomous enterprises, and both agentic and physical AI are key pillars of that future. To the degree that LLMs have increased Palantir's margins by making digital twins easier to deploy and use, the next two AI waves will do so considerably more. This is because these two types of AI will enable the creation of autonomous employees to emerge from Palantir's platform that will be capable of performing actions both in the virtual and physical space automatically. This would exponentiate the value delivered to Palantir's end customers at a marginal cost, since all Palantir has to do is plug these new AI models to their customers' digital twins, and they can do that quite cheaply. Palantir stock is down over 30%, which is fairly typical of growth stocks of this sort after good positive runs. As I've discussed recently, the market is attempting to price in the company's exponential fundamental progress. The volatility is the result of essentially no one understanding how to price a company evolving in this manner. However, Nvidia is perhaps the world's first instance in history of this phenomenon, and it's ironic to see that investors were actually paying just 19 times earnings for the company just a year ago. Nvidia teaches us that in winner-takes-all scenarios, it's more important to make sure you're betting on the actual winner than making precise calculations of the company's intrinsic value at at any given point in time. Nvidia investors have won because they spotted exponential growth early, and while there is no guarantee of success for Palantir, I see a similar pattern in play. Going back to AMD, what was obvious to me during the Nvidia Q4 2024 earnings call is that AMD is a specialized player while Nvidia is a generalist player. Let me explain. When asked about ASICs, Jensen explained in the Q4 2024 earnings call that Nvidia's ecosystem is generalist. ASICs are chips that are built for a specific neural network in the context of AI. Thus, ASICs tend to outperform general GPUs when running the specific AI workload they've been built for. Jensen's reply gave me great clarity on AMD's competitive advantage in the AI field, which is specialization at a marginal cost. Here's what Jensen said about this during the last earnings call.
Well, we build very different things than ASICs. In some ways, completely different. In some areas, we intersect. We're different in several ways. One, NVIDIA's architecture is general. Whether you've optimized for autoregressive models or diffusion-based models or vision-based models or multimodal models or text models, we're great at all of it. We're great at all of it because our software stack is our architecture is flexible, our software stack ecosystem is so rich that we're the initial target of, most exciting innovations in algorithms. And so, by definition, we're much, much more general than narrow. We're also really good from the end to end, from data processing, the curation of the training data, to the training of the data, of course, to reinforcement learning used in post-training, all the way to inference with test time scaling.
While I don't expect Nvidia's approach to yield anything but exponentially growing revenues over the long term, Nvidia's generalist approach leaves a large gap in the market for AMD to fill. While in the past I've been vocal about AMD's inference advantage, the implications of its platform are actually much broader. Meta's Llama 405B model running inferences exclusively on AMD's MI300X chip is at a higher level, the result of AMD being able to personalize chips at a marginal cost, with a clear total cost of ownership advantage. In one of her latest interviews, Lisa Su explained that the traction on the inference side is the result of tactics, implying that what they've done is leverage their highly versatile platform to bring Meta, among other customers, a chip that AMD felt would best address a specific niche. Despite its extraordinary success, Nvidia can't do that because its platform is geared for a generalist approach. AMD's platform has enabled them to add an unusually high memory capacity in the MI300X, which then brought Meta on board. I believe that as AI continues to mature, with the aforementioned scaling laws evolving and agentic and physical AI coming into the scene, the variety of AI workloads in the world will explode to the upside. AMD's ability to produce specialized chips at a marginal cost will likely be its competitive advantage over the next decade or so. Further, what this means is that AMD's ROCm, the equivalent to Nvidia's CUDA, doesn't actually have to catch up to Nvidia's CUDA at face value. It just has to get good for whatever specialized chips AMD brings to the market that Nvidia's can't quite compete with. Lisa explains this concept elegantly in her last interview at Stanford.
Again, I view that you're going to have AI end-to-end in different compute sizes. There's no one size fits all in AI, and the open capability is just part of AMD's DNA. Like, that's who we are. Like, we believe in letting our customers and our partners choose what is the best component in each spot. Now, what that means is we do take on some extra work in terms of interoperability. We absolutely take on extra work. However, we believe in the end, we'll get a much larger developer ecosystem, as part of that. And so that has been our mantra. And what you'll see in AI today is, people actually, we're in a race to get to the next great app or the next big wave of usability. People want to make it as simple as possible, and that's what we're working on, is how do we make access to AI as simple as possible as you go forward.
All right, that's it for today. Thank you very much for joining me. As always, if you enjoyed this video, could you please share this with one friend? These deep dives are for free, and so the only way this grows is with your help. Thank you very much in advance. Take care, and until next time.